All right, and we're going to continue our conversation about solving today, and you're going to see a very big connection to what we did yesterday, all right, in the previous lesson, and all we're going to do is add one more particular step, all right, to our work. So, in a very similar fashion to what we did in the previous lesson, we have an opener here with 4 different graphs, and so like we did in our prior lesson, all right, okay, I want you to graph, all right, x minus 4, y equals 4, tell me where they intersect, and then so on all the way to part D. And once again, this is going to continue, right? You can see standard 10 here. I can solve linear, absolute value, quadratic, and exponential equations. All right, so once again, making that connection between solving, all right, and systems of equations. So pause the video, do those 4 graphs, and flip it back on, and we'll see how you did. All right, so let's take a look. All right, so when you look at our first graph here, all right, we start at 0, -4. All right, our line goes up by 1 over 1, and you can see eventually we cross y equals 4. All right, and so our solution or our point of intersection would be 8, 4. All right, now moving on to B, our absolute value graph here. We start at 0, -4. Our rate of change is 1 over 1, and if we keep extending, all right, we go up and we intersect twice now, right? -8, 4 and +8, 4. All right, looking at our quadratic here. All right, so sorry about that. We can see that, oh, I didn't draw in my horizontal line here. Y equals 4. All right, we get our 2 points of intersection. All right, -3, 4. All right, and I think I totally goofed that up. All right, nope, this should be a 5 here. Sorry about that. I think I changed that. All right, so -3, 4 and 3, 4. All right, for your points of intersection. All right, and we look at our exponential here. Our floor is -4, all right? And if we continue our pattern here, we get another point of intersection at 3, 4. All right, so the only difference between yesterday and today, right? So notice that we are at a different y value here. So y equals 4 versus y equals 0. So how does that affect, all right, our solving? All right, so now, once again, all right, when we look at this work, all right, when we're looking for our points of intersection, we want to set those 2 functions equal to each other, right? And so notice I'm still going to do x minus 4 equals 4. Now the difference is yesterday it was already equal to 0, so we could use that 0 property. So the change for today is that I want to make this 0, so then I can go back to using that 0 property like we did yesterday. So notice if this is a positive 4, the way I make this 0 is I'm going to subtract 4 from the right-hand side, and that makes it 0. Now, if I subtract 4 from the right side, I also need to subtract 4 from the left side, all right, to balance my equation. And now I want to line that up with the other number, all right, because those would be like terms. So I'm going to subtract 4 like that. All right, so I bring down the x, and then -4 minus 4 is -8. So I get x minus 8 is 0. And now I can use that 0 property. So what minus 8 is 0? That would be 8. All right, and then, all right, x equals 8. And so once again, you can see, right, that is exactly where, all right, we intersect. All right, now going on to this one, right, the absolute value of x minus 4 is equal to 4. So once again, we want to make this 0. All right, so we can use that 0 property of addition like we talked about. So I'm going to subtract 4 here. That's going to make the right side 0. I'm going to subtract 4 on the left side to balance my equation. So I get the absolute value of x, and then -8 is equal to 0. And then once again, now I can use that 0 property. What -8 is 0? +8. Whatever's behind my hand must be, all right, +8, and that would be the absolute value of x. Now, what numbers have a distance of 8 from 0? That would be -8, all right, and +8. Okay, so now, all right, I got to adjust had a little typo there, x squared minus 5 is equal to 4, right? So x squared minus 5 is equal to 4, all right? And once again, right, subtract that 4, make that 0, all right, equals 0. So x squared minus 9 is equal to 0. So then what minus 9 is equal to 0? All right, what minus 9 is equal to 0? That would be +9, so x squared is equal to 9. Now, what number times itself as 9? -3 times -3, and +3 times +3. So you can see that we're really doing the same process as what we were using yesterday, except for yesterday we started on this level right here. So we're just adding one additional step so we can use that 0 property. Same thing for our exponential here. 2x minus 4 equals 4. I want to make this 0, so subtract 4, subtract 4. That's 0. So 2 to the x minus 8 is 0. All right, so what minus 8 is 0? That would be 8. And so 2 to the x is equal to 8. Now, how many 2's do I need to multiply, right? So 2 to the first power is 2. 2 squared is 2 times 2, which is 4. And then 2 to the third power is 2 times 2 times 2, which is 8. So this would be x equals 3. All right, so you can see that we're really doing the same thing we did yesterday, right? But we're adding this one little additional step here. All right, so now let's go to page 16. All right, now once again, I want you to go ahead and graph E, F, G, and H here. All right, find those points of intersection if they exist. All right, flip the video back on and we'll see how you did. All right, so here's my work. All right, so on part E here, we start at 0, 4. Right, that's our starting point for our line, and we see I have a rate of change of 1. Now notice we're trying to intersect negative 4 here. So notice I need to reverse my slope until I get to my point of intersection, which is negative 8, negative 4. All right, now, very similar fashion to what we saw last time, right, in our previous lesson. All right, I'm starting at 0, 4. My absolute value graph opens up, but here's y equals negative 4 down here. All right, so we can definitely see there's no points of intersection, so there is no solution to this problem. All right, you're going to see this in a very similar fashion with our quadratic here as well, right? Our vertex is 0, 4. It opens up. All right, it definitely does not intersect y equals negative 4 down here, right? So another no solution problem. All right, with our exponential, our floor is already at 4. All right, and then we go up 1, up 2, up 4, up 8, right? And we can see our exponential graph is definitely not going to intersect y equals negative 4. So once again, we get these no solution problems, right? Because there is no point of intersection, right? These graphs do not intersect. Now, how does that play into, all right, our solving equations, right? So once again, we always kind of go back to what we know, right? This is going to be our equation, x plus 4 equals negative 4. So once again, the goal is to get one side of our equation equal to 0. Now notice this time, it's equal to negative 4. So if I want this to be 0, right, I have to add 4, right? They have to be opposites. Once again, we're going back to that 0 property of adding, right? So in order to be 0, I have to have opposites, right? So this is going to be equal to 0. Now once again, I have to balance my equation. So if I add 4 on the right side, right, I also have to add 4 on the left side. I'm going to line that up with the other number, right? A number goes with a number, a variable goes with a variable. So this is x plus 8 equals 0. Now, what plus 8 is 0? Negative 8, right? They have to be opposites, which means x has to be negative 8. And then once again, right, we can see that that is definitely the point of intersection here, right? Okay, definitely intersects at negative 8. All right, now moving on. Looking at our other equations, absolute value of x plus 4 equals negative 4. All right, so once again, if we're going to make this 0, I'm going to add 4. And I'm going to add 4. So the absolute value of x plus 8 is equal to 0. Now, what plus 8 is 0? Negative 8. So now, here's where the no solution comes in with just equations, right? We know an absolute value can't be equal to a negative, all right? So this is the no solution part. All right, if we look at our next two equations, right? Set them equal to each other. X plus 4 equals negative 4. Make this 0. Add 4. Add 4. So x squared plus 8 is equal to 0. So once again, what plus 8 is 0? Negative 8. All right, so that means x squared is equal to negative 8. Once again, we know from what we've discussed last couple lessons, right? A square, a quadratic can't equal to that negative number. So there's where the no solution comes in. All right, but we have to get to this step, right? And that's really important that you have to get to this to interpret that no solution when we're solving equations. All right, so one more here. 2 to the x plus 4 is equal to negative 4. All right, so once again, we want to make this equal to 0. So I'm going to add 4. I'm going to add 4. So 2 to the x plus 8 is equal to 0. All right, what plus 8 is 0? Negative 8. All right, so 2 to the x is equal to negative 8. All right, so once again, if we're only multiplying positive 2's, we'll never get to a negative number. All right, so that's why it's no solution. All right, so this is really the big step for what we're going to do, right? So we're going to, this idea that we always want one side of our equation to be equal to 0 when we're solving. All right, so when we look at a couple of examples here, right? Okay, so when I look at this first equation here, notice I have a positive 14 over here. So the way I make this 0 is I have to subtract 14, right? So 14 and negative 14 is 0. And then I have to take and balance my equation, so I also have to subtract 14 on the left side. And a number goes with a number. So I'm going to line that up here, combine those like terms, right? And I get negative 51 plus x is 0. And then once again, right, negative 51 plus what is 0? 51. We know they have to be opposites. All right, we know they have to be opposites. Notice over here, I have a negative number, right? So to make this 0, I have to add 31. Once again, then I have to line them up over here. I have to add 31, number to number, 78 plus x. So 78 plus what is 0? Negative 78. All right, so that's going to wrap up our video for today. All right, we're going to now take these concepts into class, right? All right, and just keep expanding and working on our solving. So see you then.